So in this video, we are going to talk about the Hess's law, and what this law says. It basically says that any reaction which can be divided into multiple sub-reactions or intermediate reaction. If we have that kind of reaction which have multiple steps, then the sum of the energies is always equal to the sum of the individual steps. So let's say assume we have a kind of reaction which is say A plus B equal to, say, we are getting P plus Q, and then we have some delta H here. Now this is our overall reaction, but the reaction might happen like this. Say A plus, say, maybe O2, it is giving you AO2 plus some energy here. Then AO2 is reacting with something. I'm just giving an example, students. Okay, so B, so maybe it is giving you AO2. Then we have this B here, and then we say AO2 B plus it is reacting with something maybe like P, and it's giving you, I'm just going to write here P. This is not a right way of writing it, but I'm doing it for your understanding. So this one, we have this energy E3 here, and don't go by this sign because they seem like they are all exothermic, but I'm just assuming we have delta H here, some values. Okay, so when we combine these, and then we can see maybe like say at the end we are going to say Q equal to Q, and then we say delta E4, and let's do it. So just for your understanding, okay, so we have to start from here. So now you know AO2 will get cancelled with AO2, AO2 will be cancelled with this, okay, and then we should not have cancelled it, but I'm doing it here. Say some X is there, and Q plus X, say let us giving us Q, so X and X cancel. Finally you're getting A plus B equal to P plus Q, something like this. The main thing is you have to add these energies now, so that will be your total energy, the sum of all energy, E1 plus E2 plus 1. So it says that basically when your reaction is multi-steps reaction, then it can be treated like mathematical equations, and you can do plus, minus, multiply, divide, all the whole equation together. As long as you do it, your results should be same, and these calculations should not affect your overall result. It helps us a lot to figure out the total change of energy when the section is having multiple steps. I will take an example from here. So let's take an example. Say we want to find delta H for this reaction. Okay, so in this case now the strategy is these are the three reactions that you have to use for that. So you need to look for where are the reactant. So reactant is this and this, and you have to look for where these reactants are here. So you can see C2H4 is here. So I'm using this equation. I'm going to C2H4 plus 3O2 equal to 2CO2 plus 2H2O, and delta H is negative 1411 kilojoule. Now I have to look for H2. Where we have H2? H2 is here. So combine that also. So you see H2 plus half O2 equal to H2O, and delta H in this case is negative 285.8 kilojoule. Okay, so the thing that I'm looking for in the product side is only C2H6, but that need to be in the product side. So now this is the reaction, but C2H6 is in the product side. So what we do, we flip this whole reaction. So we do 2CO2 plus 3H2O equal to C2H6 plus 3.5 O2, and remember when we flip it, delta H sign will also change. So instead of negative, now it will be positive 1560 kilojoule. And let us try to add this reaction. So let us see what we can do here. I can this 2CO2, they will cancel with 2CO2 here. I can see here two water molecule, three water molecule. So I have three water molecule here, so they will cancel. Okay, then I have 3.5 O2 here, and I have 3.5 O2 here, also they will cancel. And at the end I'm left with C2H4 plus H2 equal to C2H6, and then you have to do delta H by adding all those. So negative 14, 1, 1 plus negative 285.8 plus you do 1560 kilojoule, and that will be your answer. Okay, so when they give you this kind of work, you can do that by rearranging the equation. Let me take one more reaction. So say we have this reaction here. Calculate delta H for the reactant where 4NH3 plus 5O2 is giving you this. So again, look for the reactant 4NH3. Now you see NH3 here, but it's only 2NH3. So what we do, we make it 4NH3, and I'm also flipping it. Now what I did here, I multiply this whole reaction by 2. So make sure you multiply whole reaction by 2, and then it will become 2N2 plus 6H2. Remember, I am multiplying the whole reaction by 2. Please remember it. And then we have delta H. Because I flipped it, sign will change, and I have to also multiply it by 2. So it should be 6, 3, 183. Okay, so delta H is 183 with the positive sign. We are done with this part. Now we have to look for O2 in the reactant side, but we have two O2. I'm not sure which one should take, so I will go with this NO on the product side. So NO on the product side, it's already there, but again it is doubled. So let us do this. We do 2N2 plus 2O2 equal to 4NO, and delta H has to be doubled here, but with the same sign because I did not flip it. So it should become now 370 kilojoule. Pardon my math if it is wrong. Okay, I'm just doubling this part too. And next one is here we have 6 water molecule this side. I have to see where we have water molecule here, and there are 6. That means I'm timing it by 3. So time it by 3, and then you see here, so now this will come 6H2 plus 3O2 equal to 6H2O, and should I take the calculation help here? So I'm going to say equal to 483 point, what was the value there? Sorry, 483.6 times 3. 6 times 3. So let us see if it gives us some value. So 1450.8. So let us go back now, and we see here delta H is 14. What is the value? 1450.8. So let me write it 4051, and we are not changing the sign for this because in the same side putting it negative here. Okay, the signs are important, students. Okay, so also we did not change this 4NO, so we have to keep that also negative sign here, but this was flipped, so I have to change the sign. Now let's try to combine them. So when I combine them, I should be able to get my original equation, so that I need to check. 2NO2, this cancel with 2NO2. We have 2 plus 3, 5O2, and I think we need those 5O2. And then 6H2 and 6H2 is cancelling. So I'm getting 4NH3 plus 5O2 equal to 4NO plus 6H2O, and you have to add all this. Means you have to do math for this. When we say add, don't just keep on adding them. You know that this sign is positive, this sign is negative, this is negative, so you have to do this math and get the final value. Okay, that's how we are going to do Hess Law. Okay, and I think this is good for today, so we'll look into the last part of this unit, that's about rate of reaction. Thank you.